So in an electrolytic cell, one thing that makes an electrolytic cell different is this time where we used to have a salt bridge and we used to have two separate containers, or a container with a membrane to allow for the ions to pass through. In an electrolytic cell, it is only a single container with a single solution. Both electrodes are still placed in here, and what happens here now is that we are going to introduce a current into this system. Okay, but still electrons are going to flow from the anode towards the cathode. Now if I look at that, this is my battery. In my battery, the longer line is the positive, which means it is the one that's receiving electrons. It's attracting electrons. So electrons are flowing towards it, making this the anode, and that one that's flowing away, making that the cathode. Now, as a result, the cathode is electron rich. So the cathode is willing to donate electrons to whatever ions in the solution wants electrons. So in here I have a solution that wants electrons. From the anode side, okay, it becomes positively charged because it is giving away electrons towards the positive side. So, and it's connected to the positive side. So on this side, anions are attracted, because it's positive, the anions are attracted here towards it. Anions are usually with an X, sorry, are attracted to there. So on this side, anions, which are electron-rich ions, they've got extra ions, electrons, come here, they give their electron away, their extra electrons away, which means they become pure substances. Now, what could that be? That could be something like oxygen. So for example, if I had some water here, so if this is water, and in this water, water itself doesn't conduct electricity because water doesn't ionize into ions. So I need to put ions in here. So a little bit of salt or bicarb or something in that mix, that just allows the current to pass through. And if I do that, the hydrogen in the water will, so then we have hydrogen, which is positive, and oxygen, which is 2 negative. Then the oxygen has extra electrons now, and the oxygen will come and donate its 2 electrons here to this bar, okay? And on this side, electrons being supplied by the battery will be donated into the solution. Now, who wants electrons? Hydrogen wants electrons. So hydrogen will come and get himself an electron from here. And as a result, hydrogen will form at the cathode, hydrogen gas will form, and at the anode, oxygen gas will form. So what we will have is hydrogen, we will have H plus donating electrons, getting electrons, producing H2, and then we have oxygen that is donating its electrons, so it's producing oxygen, or the oxygen ion producing oxygen and 2 electrons. Okay. And this is called the hydrolysis of water. In other words, breaking up water molecules into oxygen and hydrogen. And then usually what you could do is you could have this be, for example, in the course as well, I put a video of a guy that did this experiment with, you know, those square batteries, rectangular batteries. They look like that. So he just puts one of them in water, and he puts some salt in it, and then you see bubbles starting to form at the two ends. And what you see, if you need two of these producing one oxygen, but what you see in the end is, since you have H2O producing H2 and O2, there's two hydrogens that is forming like that. Okay, the amount of hydrogen forming is double the amount of oxygen forming. So you literally see at the cathode, in other words, that's the negative of the battery, you see hydrogen forming literally double the amount as the oxygen. And then he puts little test tubes in here, and he just catches the bubbles that's forming, and then he shows you that the one is oxygen and the other one is hydrogen. For example, hydrogen, when you put a flame near hydrogen, it makes a popping sound, so it pops. And while oxygen, if you bring a coal into oxygen, it combusts. It takes. So, for example, if you light a match, and you let it die, but you immediately put it back in, then it just takes flame again. So he shows you, it's a very simple experiment, you can even do at home, but that's a very good example of hydrolysis and how and this is called the electrolytic cell, or the electrolysis of water. Is it called hydrolysis? It could be electrolysis of water, but this is an electrolytic cell, works like that. So you can see in the galvanic cell we use a reaction to create a current. In this one we induce a current to cause a reaction. Okay, do you see the difference? And so a variety of ways can then be used, because you are literally using a current to produce a compound. This is often used with electroplating. So for example, how do they actually plate a piece of chromium or whatever? How do they actually make gold-plated earrings? It's exactly using this system. They have a solution. So if I wanted to plate something with gold, I will have on the one side, I will have a piece of gold. Okay. On the other side, I will have the thing that I want to plate. I will send a current, and this obviously has to be a conductive material, so they have to make it from metal or aluminium or something. Okay, and I'll have my piece of gold here, and then I need a solution, and in this solution I will need my sorry, I just want to think of something. Whatever you make, in my solution I will then need that my gold ions, so you'll obviously probably have something like gold nitrate solution or something, and then as the reaction happens, gold is being donated from the ions. So in other words, electrons must be going in that direction, and so the thing that you want to plate with, so if I want to plate with gold and I've got one of my electrodes is gold, that one obviously has to be connected to the one that's going to take away the electrons, so that the ion is donated into the solution, and on the other side the electrons are being offered again, so that this ion that was released now goes and gets his electron on that side, and when he gets his electron he forms normal pure gold again, and he plates then on there. Does that make sense? Okay, so let's just go and look at this question. The diagram represented below is an electrolytic cell that can be used to cover the fork with a thin layer of chrome. So look, there is exactly what I said. Here's the bar that I want to plate the fork with. It's connected to the positive, so it's going to take electrons away from this bar, which is going to donate ions into the solution, which on this side, now they want electrons. On this side, electrons are given to the fork, and so the ions are now tending towards the fork. They get their ions at the fork and plates, because that's where they got the electron from. Make sense? Pendile? Okay. Is the fork the cathode or the anode of the cell? So in other words, is it getting electrons, then it's cathode, or is it giving electrons, then it's anode? Sorry? It's cathode, because it's the one receiving the anode, the electrons. Write down the half reaction that takes place at the anode. So again, the anode is the one that gets the electrons. So chrome, Cr. Let's just see. Chrome, according to this, where's chrome? Chrome, yeah. Chrome 3 plus gets 3 electrons. Chrome, so chrome 3 plus gets 3 electrons and becomes chrome. So that's what's happening at the anode. The anode is the one that gets electrons. It's the one where I'm adding electrons to. Name the type of electrolytic process that's taking place here. I'm not exactly sure what type of electrolytic process is taking place here, other than electroplating. I don't know if that's what they meant. Electroplating. It could maybe be electrolytic process. It could be electric energy converted to chemical energy. What do you think? I said electroplating. I couldn't think of anything better. The chloroalkyl, no, that's a negative impact on plastics in the environment. A winged question. Okay, doesn't really have to do with electroplating. Let's see if the other paper had for us a question on it, so that we can go into, after the break, into alright, here we go. A simplified diagram below is an arrangement that can be used to electroplate a metal badge with silver. Okay. Define the term electrolyte. Okay. Ions. Yeah. So an electrolyte is a solution, is an ionic solution of ions. Write down the half reaction that occurs at the anode. So the anode is the one that yes, then I did it wrong here. Wait, wasn't that the previous question as well? The half reaction that takes place at the anode. The anode is the one that gives electrodes. So I wrote the wrong half reaction.
No, it's right. Because when you give, you become a positive.
Yeah, but this is the one that gives electrons.
Yeah, so that's the anode.
Yeah, this is the anode. But look, I wrote the wrong thing. It is the chrome that produces chromium and 3 electrons. So it is giving away into the solution, it gives that, and into the circuit it gives that. Okay. Sorry about that. But then, what was the first question? Is the fork the anode or the cathode? It's the cathode, yeah. So, yeah, that's right, okay. Is that what we said, cathode? Okay, cool. So at the anode is the one that gives. So before we actually answer that, let's just see what is going to happen here. This one is going to be plated. Where is he going to get his silver from that he's trying to plate with?
From the solution.
From the solution. What must he have in order to get the silver out of the solution?
Negative charge.
In other words, he needs electrons.
Electrons.
Okay. Which means he's getting it from the circuit. So he is receiving electrons. Make sense? So he is the anode. No, cathode. Sorry, cathode. I thought that this one is then the anode. So what is the half reaction that occurs at the anode? Well, this is the anode. He's the one that gives away electrons and gives away cations into the solution. So since it's silver, the anode gives away silver into the solution. Let's get to my table. Do I see silver? Is silver? Yeah, it's just one. Okay. He gives away silver and one electron. This he gives away into the electrolyte. That he gives away into the circuit. Okay. Or actually this one he's not really giving it, it's being taken from him by the positive charge on the battery. He's attracting it. So he's forcefully giving it. Okay. The formula of the metal of which electrode Y is made of, that's just Ag. The formula for a suitable silver solution that can be used, silver nitrate. Okay. Why is DC power supply needed in an electrolytic cell? We're going to use alternating current.
Because with alternating current, as it says, it is alternative to the current.
Yeah. Alternating current will literally the whole time swap what's happening at the whole time. Yeah. As a matter of fact, that wouldn't cause an explosion in an electrolytic cell, I read. Okay. We can't use alternating current because it will keep changing the half reactions that occur. So okay, so you could say we need the electrodes, the half reactions to occur at the to be constant at the half reactions. Give a reason why the concentration of electrolyte remains constant during the electroplating. Why does the concentration, if I start with a certain concentration, why does it keep constant? Why isn't becoming it more dilute? Because I'm now plating this thing with silver. Why isn't it causing you guys suck. You don't want to think, that's the problem. Also,
If you used a different concentration, wouldn't that like affect the whole thing?
no, it will stay constant the whole time.
Isn't those
And yet we're taking silver out of the solution to plate. How on earth is it not becoming? Why is the solution then staying constant?
because we need it to stay constant.
No, I know it is staying constant. But why? How is that possible? We're then taking out and plating the badge. Why is it? Why?
Maybe not all the silver is being used up.
No, the point is, if I take one ion out of there,
Aren't you ready?
yes, we're adding ions back. That's why we have this bar. For every ion that is plating the badge, another ion is being, because if I take an ion in here, it means an electron that was donated here. Where did that electron come from? From the battery. Where the battery can only give an electron if he received an electron. It's like a tube. If you had a tube like this, if I push an electron in here, it will push an electron out. So that's how a battery works. Like it's only donating an electron on this side because it received an electron. But where did the battery receive the electron from that it's donating here? The battery received the electron from the silver, because the silver donated its well, it was forcefully taken. But that left a silver ion. And so the ion was donated back. The one ion is given, the another ion is then donated. So one ion is plating, another ion is being donating. Or not being donated. What?
Physics.
No, come on. Lazy students that don't want to think.
So we're not lazy.
Of course you are. If you don't want to think, you are lazy. You guys want to be spoon-fed. Give me the answer. Give me the memo, then I'll do well. Okay. Guys, best advice I can give you is go through as much past papers and do these ones. Especially these last few questions. Like from fertilizers. So easy. There's just not that many questions they can ask you. What is it? This one, okay, titrations, they can make that difficult, but electrochemistry, oh, it's so simple. I've seen some complicated ones, yeah, but go and look at these easy topics in chemistry. Is your electroplating or your electrochemistry and fertilizers. Go practice a lot of them so that you can make up marks. There's 10 marks, you can really get full marks for them. Okay. In physics, it's going to be what we did yesterday, electrostatics. It's very easy. It's really easy. Electrostatics and the photoelectric effect that we're going to do after we take a short break. Okay.